Okay, in this video I'm going to provide a basic demonstration of how to create a vector of scores in R and also how to generate some basic descriptive statistics. So the first thing that you need to understand is that R basically operates on objects. So there are various data objects that you can create in the program, and right now we're just going to be focusing on one type of data object, which is a vector of scores. So let's say for argument's sake that I have a variable that I just want to call x. And let's just say that we're going to create a vector of scores on x. So what I'm going to do in R right here is I'm going to type in x, and then I'm going to type in an arrow. And the arrow just is formed by typing in a less than sign and then a hyphen. So that creates an arrow. And now what I want to do is to input some scores for this particular vector. So what I'll do is type in C, and so this is a function that is used when you are typing in values on a variable or whatever. So next I'll type in a parenthesis, and then I'm going to type in values on this variable x. So I'm going to type in a 3, comma, 1, comma, 2, comma, 4, comma, 5, comma, 6, comma, 2, comma, 1, comma, 5, and 4. So right here now you'll see that I have what I'm creating is a data object. Again, it's called x, which is essentially going to be my variable, and then the scores on that variable are reflected inside the parenthesis here. But to enter those scores I have to use the C command prior. So now I'm going to hit enter, and so now you can see we go to the next line. So if I want to see the scores, I can just type in the name of the data object. In this case, it's just x, and then hit enter. And so there you go. Now let's get a little bit more sophisticated. Now we're going to actually type in, I'm going to type in a new variable, create a new data object for a variable called test score. So I'm going to type in test score, and then I'm going to type in my arrow. So again, it's the less than followed by a hyphen. And then I'm going to type in C, and then inside the parenthesis I'm going to type in some test scores. So imagine these are test scores from a set of students. So I'm going to type in 88, 95, 72, 91, oops, 82, 78, 61, 100, 99, 81, 85, 87, 84, 88, 92, and 96. And then in parenthesis. So now what I'll do is I'll hit enter, and so if I want to see those scores I can just type in test score, and there you go. So those are all the scores that I just typed in. So now you can see that I basically have, again, I have a vector of scores for my variable, which I'm going to call test score. And so now let's say I want to compute the mean for the test score variable. So what I'll do is I'll use the mean function. So I'll type in mean, and then inside the parenthesis I'm going to use the name of the data object that I created, which is test score. So I'll type in test score, and in parenthesis here, and then hit enter. And so now you can see that the mean test score is 86.1875. If I want the standard deviation, I can type in SD, and then the name of the data object, which is test score, and it is 10.15. Okay. If I want the variance, I can use VAR, and then the name of the data object, again, test score, which is 103.0958. If I want the minimum score, I can use the min function. So I'll just type in MIN, and then the name of the data object, which is test score, which is 61. If I want the maximum, I can type in max test score, and you can see it's 100. So the minimum value in the data the data set is 61. The maximum value is 100. If I want to get the median, I'll just type in median data object, and it's 87.5. If I want the range, I can use the range function, and you can see it's the 61 to 100. So just note that essentially what you see, the C right here is a function. Mean is a function. It's basically we're operating on the data object. SD is a function which is being operated on the test score object. VAR is a function being where we're operating on test score, and so forth. So all of these are functions followed by, within the parenthesis, the name of the data object. Let's look at quantile. So I can type in quantile and then test score. And so now you can see that we get the different quantiles in the data set. So there's the 25th percentile, 50th, 75th percentiles right there. Now, so these are a number of different descriptive statistics that we can ask for. We could also ask for histogram of the data. So I can generate a histogram by typing in HIST, or basically using the hist function. And then inside the parenthesis, we'll type in test score. And so now you see that we get the histogram for test score. So you'll notice that along the x-axis we have the scores, along the y-axis we have frequencies, and you'll notice that the score intervals are essentially 10. So now what we can do is, if we don't want frequencies but we would rather have relative frequencies, we can do that by typing in the following. So we'll type in, using the hist function again, then we'll type in test score, comma, and then we'll type in FREQ. So this is an option, and then follow it by an equal sign. And then if we want the relative frequencies or the essentially the probability densities, we'll then type in, we'll type in false. And essentially the false has to be in all caps, so make sure that you do that. So now what I'll do is I'll hit enter, and so now you see densities show up on the y-axis. We can also modify our histogram even more. Let's say that we want to have more breaks in the data. So let's say we want to have more score intervals represented. So what we can do is we can type in hist, then test score. We'll go ahead and stick with our frequency as false. And let's type in breaks equals 6. So you'll notice that the default right here, we were given essentially 4 intervals. So now if I hit 6, you can see that we have more intervals that are being represented in the data. Just for completeness, let's say that we want to do this with 15 intervals, or 15 breaks. So we'll type in test score, frequency, which is equal to false. That's our option there. Our other option of breaks we'll set at equal to 15, and then we'll hit enter. And so you can see that this is what it looks like. We can also modify the graph by adding in labels and titles. So let's try now, let's add in a label on the y-axis. So let's say I don't want to stick with just test score down here on the on the x-axis. But let's say I want to change that. So what I'll do is I'm going to type in, I'll just type in this as before. And then I can use the XLAB option. So that's for labeling the x-axis. And I'll type in equals, and then inside a parenthesis, whatever I want to appear on the x-axis. So I'll type in this case, just for demonstration, I'll type in student test scores, and then in quotation marks. So you got to have, following the XLAB option, you have the equals, and then inside the parenthesis, whatever you want to appear. So then, inside the quotation marks, what you want to appear. So then I'm going to, in this parenthesis, close it out, and then I'm going to hit enter. And so now you can see down here it says student test scores that are appearing on the x-axis. If I want to change the y-axis, I can do that as well using the YLAB option. So let's just keep going. We'll do test score. We'll just keep this all the same. And we'll use XLAB as before, student test scores. And then we'll use YLAB, and then we'll type in equals. And I can continue on, but you'll see that it kind of runs off, it'll end up running off the screen. So what I can do is, and as long as I don't close out this parenthesis right here, I can actually hit enter, and you'll see that on the next line it starts with a plus. So we'll just continue on our commands. So in this case right here, I'll type in for the label on the y-axis, I'm going to type in probability density inside the quotation marks. And now let's say also that I want to add a new title as well. So let's say I'm not content with just the title being histogram of test score as you see it right here. Then I can also type in main, and so follow this up with equals, and then inside quotation marks I can offer a new title. So in this case I'll just call it histogram of student test scores, and then I'll hit end parenthesis, and so now this is going to close out the set of commands. And so now you can see we have along the x-axis student test scores, along the y-axis probability density, and the main title you see it says histogram of student test scores. So we've done all that with the set of commands that we've just walked through. Now we can also ask for a kernel density plot if we wanted to kind of get another view of the data. So what I'll do in this case is I'm going to type in plot and then follow this up with density, and inside the parenthesis the name of the data object, which again is test score. And then if I want, so in this case let's just say I want to end this with two parentheses. Basically, you'll notice that we have one parenthesis that's surrounding density and test score, and then another one surrounding test score. So we're going to have two end parentheses over here to close out both of these. So if I hit enter, you'll see that this is the plot that we see right here. I can also add in labels in the same way that we did before. So let's say I do plot and then density, and then we'll type in the data object test score as we did before, and then in parenthesis for that type in comma and then xlab for labeling the x-axis, and in this case I'll just type in inside the parenthesis test scores, and I can also do a main as well. So let's just say, oh, I need to end the quotes right here. We'll type in main equals, and then we'll just call this kernel density plot. So now you can see that we have the name of the plot right here, and as well as test scores appearing down below on the x-axis. So those are just a couple of demonstrations of how to graph, how to generate different plots, if you will, of our test scores. Now let's say that we want to generate a set of descriptive statistics a little bit quicker than what we've been doing. There's a couple of options that I've run across that involves a couple of different packages that you can download or install to R. So one package that I'm going to refer to is the psych package, and I actually have you can actually find this if you go to this particular web page right here. The other one is called is basically PASTECS package. So I'll demonstrate a little bit of both of those right now. So the first thing that you have to do, if you haven't already downloaded and installed the psych package, you're going to have to do that if you want to use it. So what we'll do is I'll just demonstrate what to type in. You'll type in install period packages. Okay, so this is a function right here, install.packages. Inside parenthesis, you're going to type in the name of the package. So we're going to type in a quotation mark and then PSYCH and then end quotation marks. So this is going to call up the psych package. So I'm going to hit enter, and you'll see that when we do this, a little menu pops up here right here. Basically, you're trying to figure out where you want to install the package from or download the package from. So these are all different mirror sites that we can pull from. So I live in Oklahoma, so I'm just going to go ahead and use Texas right here and click on OK. And so now what you'll see is that the program is being installed, and there you go. So it's been installed. So now if I want to use this, I can use, what I'll have to do though is I'll have to call up the package. So you can't use the functions in the package unless you call them up. So I'm going to type in library, and then inside parenthesis I'm going to type in psych right here, then hit enter, and so now it's ready to go. So now I'm going to use the describe function. So describe, and then inside the parenthesis, now I'm going to describe that our data object, which is test score. And so now you'll see that we get, it just says variables 1, n 16, the mean is 86.19, standard deviation 10.15, median 87.5. You'll see the min-max range right here, and you also get a skewness and kurtosis statistics over here. So you can see that we've gotten a lot of the same information that we had obtained previously. Now let's try a different one. We'll try the PASTECS package. So in this case, if I want this package, then I'll just type in install period packages, and then inside the quotation marks I'll type in PASTECS in quotations, and then in parentheses. So now we'll go through basically the same process as before, and so it's already evidently read in, and it's ready to go. So now I'll use the library function to call this package up, and so it's ready to go. And so I'll use, in this case, the stat period DESC function, and then I'll type in our data object, which was test score again, and hit enter. And so now you can see you've got a number of values, number of null. You'll see over here you've got the sum of the values on your variable. It's the sum of the test scores, the standard deviation, median, coefficient of variation if you wanted that. There's the mean. We also have the standard error of the mean right here. And then we also have essentially a 95% confidence interval that's being reflected. Also, let me note too that if you go to this website right here, you'll see that there's more information on this particular package, the PASTECS package. But you can see it in operation. Right here, I've actually gone ahead and utilized a couple of other options in order to obtain the Shapiro-Wilk test value. That's a Shapiro-Wilk test value and associated p-value, and then also the skewness and kurtosis statistics for our test score variable. But just to kind of show you this in operation, I'll just go and type it in, stat period DESC as before, test score, comma, and then I'm going to type in basic equals true, comma, DESC equals true, comma, and then norm equals true, and then comma, and then I'm just going to go and type in p equals 0.95. That's related to the confidence interval. Hit enter, and so there you go.